This video is brought to you by Sportland, quality, integrity, and tradition. Got a beer walk-in that's not working. The lighting's all weird in here today, but the temperature controller says 49 degrees. There's no ice on the coils, so that means we need to go up to the roof and see what's going on at the refrigeration rack. Climb up the roof ladder to get to this. What the flip, man? Storing all their stuff. Well, two options. I stomp on it, I bend it, I break it all, or I politely move it. I think I'm gonna be nice today and just move it for them instead of ruining it all. But I kind of want to just stomp on it all and break it all. All right, here's my rack. Let's scroll on over here. It's a warm day today. It's not hot. We really haven't hit any hot days yet here in Southern California. It's currently June 15th. It is warm, but all right, let's get up here. And that rack is completely plugged up. Compressor is not running. Receiver's cold. I'm kind of scared. Ooh, if it was off on high pressure, you would expect that. Breaker doesn't seem to be tripped. Okay. Defrost clock, it's system C. It's not in defrost, it's in refrigeration mode. System C's pulled in though. That's scary. All right, let's come on over here and have a look what this compressor's doing. Compressor's red hot, dang it. Check the low pressure control. It is not open, or dual pressure control. Come over to the compressor, and from one leg to one leg, we have 201 volts. Let's go ahead and go to another. 201, and then let's go to this one. 200 volts. So we have three-phase power going to this compressor. It is not running. I'm hoping it's off on overload. The condenser's plugged. I'm gonna go get a water hose, a compressor cooling tool. We're gonna cool this guy off. We should be able to check to see if it resets at the compressor contactor. The other concern that I have is that this condenser fan motor is not running. It should be, but it also depends on what circuit is connected. This pressure control goes to one of the fan motors. They wire in series. There's a pressure control on each one of those. 1, 2, 3, 3 of them. And they make the condenser fan motor stage on and off. I think that the condenser fan motor for this guy is I think these two share the same condenser fan motor, so we'll have to check that too. If we come over here, this is my condenser fan motor contactor. My condenser fan motor contactor, it looks like they're all wired in together because there's only one contactor, and it feeds both sets of fuses for both condenser fan motors. So the top of this one has 201 volts, so that's one fan motor, and the top of this one has 201 volts. That's the other fan motor, but that's the line side. Let's go to the load side. We have no voltage coming out those fuses, and let's go to this other fuses. And we have voltage coming out of these fuses. So this condenser fan motor number 1 has power. Let's go across this guy. It's not open. Let's go across this guy, and it's open. 201 volts. We're measuring because the fuse is open. So we also have a bad fuse, which could be a bad fan motor, we don't know. Yeah. And actually, look at this. These condenser fan motors run all the time. They don't even stage because someone has these wire nuts right here. So it looks like those yellow wires used to run to those pressure controls, and I don't know why they're disconnected. I'm not gonna start connecting those back right now. Right now, we're just gonna get these operational. So we're gonna go ahead and shut this equipment down. We're gonna shut down the whole rack. And we're going to get my compressor cooling tool, my water hoses, my coil cleaner and stuff, and we're gonna try to cool this off and get this compressor restarted, hopefully. Came over here, pulled the side panels off. I haven't gotten my tools yet, but just looking at the condenser fan motor, I mean, it spins. Don't seem too crazy. Everything seems okay. Loosened up the capacitor strap, which I'm not a huge fan of those. And we're gonna pull this capacitor out and test the capacitor. Capacitor looks like it's testing good. Okay, now let's look at the wiring. And I pulled the cover off. I don't see anything scary. I mean, wires don't look too bad. But, you know, these can be deceiving because sometimes there's little weird shorts in these things. Interesting. I'm not seeing anything. Okay, well, I'm going to shove it back in there and we'll get a megger. We'll meg that guy. I mean, the wires look pretty good here. There's a grommet right there. The capacitor wires didn't look bad. I don't see any nicks. Everything seemed okay with that. We have gotten some rain lately, but... Oh, wait a minute. Are the drip plugs missing from the motor? Oh, man. The drip plugs are taken out of the top of the motor, but they're in the bottom. So... there's drip plugs down here. Let me see if I can get it out. There's a drip plug right there. So when you have a motor mounted like this, you should have the drip plugs taken out of the bottom and left in the top. So that way if condensation builds up, it drains down the bottom. So both of the drip plugs, I think, yeah, they've been taken out of the top, so the top is open, but the motor is closed on the bottom, so theoretically it could fill up with water. That's not good. Still don't know if that's the only cause though. All right, I got my hoses and everything up here, getting ready to cool this guy off, and I got my compressor cooling little nozzle thing on there. And I come over here, and this guy actually has tone across the legs. There, there, and there. So we have continuity. So if it was off on overload, I didn't get to check it yet until now. I haven't cooled anything, I just shut the compressor off. So now what we need to do, I don't have condenser fan motors running, but I'm just gonna start it up just to see if the compressor starts. Yeah, let's just do it and see what happens. It started up and it's running. Okay, so that's a good sign. So I'm gonna go ahead and shut it off, and we're gonna go ahead and clean the rack. So it was off on overload more than likely, but it just reset in between me getting all this stuff. So I'm gonna go ahead and clean the rack. But I tell you what, before I clean the rack, I'm gonna go ahead and run the compressor cooling tool just to get any residual cooling I can out of that thing, because I wanna meg out this motor and see if we have any shorts before I mess with anything else. Okay, pulled the fuses, there's no power. We've set the insulation tester to 500 volts. This is a 250 volt system, and we're gonna test this guy. Greater than 550 mega ohms. Okay, I mean, I don't think there's a problem. So I don't know what caused it to blow the fuse. Now, let's test it again. It should be the same because the windings are connected. So we look good as far as that goes. So what caused this guy to blow a fuse, I don't know. I don't know if there's moisture in the motor. I mean, I don't know when that motor was changed. It's an old motor, it's been there forever. We had rain forever ago. I don't see any issues. I mean, you know, sometimes there is little spots in here, little weird things. Probably recommend replacing the motor. Eliminate that from any question. We had like drizzle this morning though, so I don't think it's really enough to get in there. And if it was full of water when I pulled the plugs from the bottom, you would have seen drip drip come out. So it's not like it's saturated in there. Huh, I don't know. Okay, well, we're gonna clean the condenser now. I've got that running on there just for giggles. It reset already, but I'm just helping to keep it cool. And I'll get my wand out and we're gonna rinse this condenser off proper. All right, we're gonna start by a pre-rinse. You always wanna pre-rinse the coil, get the bulk of the debris off, the big stuff. Using a wand like this is amazing. It's just a wand from Lowe's. You can get it from any hardware store. This one's nice though because it has a rubber head on the end, so you can drag it across the coil carefully and it doesn't damage anything. So I'm just pre-rinsing. You got to be careful. I always say to put these front panels on. If you don't put them on, you just got to make sure that water's not pouring out the front, because it just splashes on the pressure controls, and while they can handle some, you don't want to saturate them. So I'm kind of being lazy right now, but I'm just pre-rinsing, getting it kind of wet, and then we'll put coil cleaner on it and do all that stuff. I think I'm gonna have to put these covers on too, because I'm gonna have to rinse the front. It is just that time of the year. For us, I don't think it's really cottonwood, but it's very similar to it. It's like a pollen that is just floating in the air. And I kid you not, I'll clean this week, and then next week it'll be plugged up again. It's just miserable. Tend to notice it more by the freeways and all that good stuff. The other thing too, I've shown this a million times, you want to make sure this is a trough that this wand is touching right now to keep the water off the compressors, and it fills up with all the sediment that we wash out of the coil. So you want to make sure you're getting that out. So I'm still pre-rinsing to get as much of the bulk off as I can, and then I'll get coil cleaner on it. Lovely. Already applied coil cleaner. I'm just rinsing it off now, and it's just coming out nasty. The bottom of the thing, just tons and tons of dirt. So I'm going to do a bunch of rinses because I got a bunch of coil cleaner on there. Ugh. These things are always a pain, especially when they don't do like routine maintenance too. But it's already looking a lot better, a lot better. Just some little boogers and stuff to get off, so I'm going to keep working on it. I'm at the point where I'm cleaning out the trough, just rinsing it from up here, flushing it, you know. I already stuck my hand up there, pulled out a bunch of stuff, but it's just pure black stuff coming out of there, because it's all just the dirt and mud and cottonwood, whatever that, it's not cottonwood, I don't know what you call it, but pollen, whatever. It's nasty. So there's a clean out on the other side too, all the way over there, so that one seems to be draining pretty good. There's a big old booger right here. Oh, it's all nasty up there. Look at the stuff I'm pulling out of there. That's nasty. Gross. All right. Just getting back. We're gonna go ahead and change out this motor. I've said it before, but this bag is badass. CTXL from Vito. Holds so much. I've got a 1/2 horsepower Knitz fan motor, bandsaw, some wire in there. Brought up refrigerant in those things before. These things are awesome. If you're interested, check out TrueTechTools.com. Use my offer code BIGPICTURE. You get an 8% discount on most of the items on their website, and then I get a small commission. Kind of helps the channel. All right, well, I'm not even gonna play with it. I'm just gonna pull that motor out. I've got a new hub and everything. I'll show you guys. We're gonna put in a new motor, and we'll assemble this guy, start it back up, and hope that everything's honky-dory. Hope that compressor runs. I mean, we only saw it run for a minute, but try to get this motor changed out first. Fan guard off, but check this out. The hubs are on backwards. I'm wondering why. Why the heck would they be on backwards like that? Because there's screws on the other side. Usually you can just pull the fan blade off. Well, hopefully I can get that thing off. I don't know if it's because of the orientation of the motor. I don't know. All right, well, we'll see. Instead of fighting it, I'm gonna see if I can just pull this bolt out and slide the motor out. Put something down metal, because those studs, you need to cut them off, but someone didn't, so the motor could slide down and, you know, puncture the coil. So always want to think about the worst case scenario, what can happen, and try to prevent it. I was starting to get worried that I put this motor in and didn't put those plugs in the right spot, but I would never do this, put the hub on the wrong side. I still can't figure out why they would have done that. There's plenty of room on the bottom of the shaft. It's just a headache. The whole purpose of these universal hubs is you could easily just change out a blade. You just undo a couple screws and you don't got to worry about sanding the shaft and everything. It's just dumb. So I got to try to get this off, because someone cut it with a grinder, which is fine, you know, but the problem is that it might be burred out, so getting it off is going to be a nightmare. All right, got the new motor ready, got the hub put on it, got it on the right direction. So now I just set the blade down and put the screws through it, and we'll be good to go. Just like that, okay? I filed down the shaft. I cut it with a bandsaw right there, and then filed it down so that way it'll slide back off. Drip drain plugs are back in the top, and they're not in the bottom. And I know what happened here, because This one didn't have drain plugs in the top. So they require you to pull them out of the bottom and put them in the top. And in the past, they used to have them on both sides, so someone probably was just moving along. But I don't think that's what killed that motor. I think, because the motor sounds like it has bad bearings when you spin it. But I wasn't going to take a chance, we're just changing it. Yeah, when you spin it, I'll try to pull it apart in a minute. But when you spin it, it sounds like the bearings are just rough inside there. So we're going to set this guy down in there right now and get the blade put on it. All right, we got the capacitor installed. We're not wired in here yet because I'm about to pull all new wire. We'll clean this up in a minute. This ground is getting deleted because I have a ground going all the way back to the panel, connected right there on the motor. All right, I went ahead and just grabbed some new wire. I'm gonna try to make a home run all the way to the motor. So I have enough here. I'm pulling it through the panel over here. And then I went ahead and cut off all this stuff in here where the wire nuts were. And there's nothing wrong with wire nuts, but I'm gonna try to make it a home run if I can. So I'm gonna get it into this conduit, over and directly into here. I got the capacitor already mounted. I got the ground from the panel coming all the way over, running through here. It'll all clean up when I'm done, so check it out. I pulled the wire out of that conduit that was running all the way over there. Bam, right there. That was my short. So trust your gut when you're doing this stuff. In these conduits, it doesn't matter if it's seal tight or MX conduit. The vibration of everything causes the wires to rub out. So trust your gut and always suspect conduits and wire and stuff. So I'm going to pull this wire back through now. So if installed correctly, see those screws, you take those 3 screws and you just lift the whole fan blade off, then you slide the motor out. I keep extra hubs in my van to make the change out easier. So we're all wired in here, connected in there. It's a home run from the fuses all the way to right here. We still got to check rotation. We're all put in here. There's no handy box cover for this, so we'll have to bring one of those back. But we got to come back anyways, because maybe you guys already caught it, but I didn't catch it. Look at that. For the other condenser fan motor, they're going into the top of that fuse. So I'm assuming that fuse is bad, which kind of worries me because there was an extra fuse right here that I used for this. So I need to make sure that that fuse is good. But we're wired all the way in here, so we're still gonna have to come back and dive in. It's like, what is it? It's 5:30. It's already, we go into overtime at 4, so I'm not looking to be here all night doing this. I just want to get this one running, so we'll see. So I need to check those fuses real quick. All right, 1, 2, 3, please don't blow up. All right, condenser fan motors are running, and we're allowed to run 3.2 amps. We're running 2.67. Now granted, I don't have the panels on yet. This one has a, you know what? We're gonna need to, this one's vibrating. The whole motor is just, because the blade's like out of balance. We'll have to deal with that. I'll tell them to create a separate work order for that, so that way I can close this one out. Oh, you know what? I need to shut it down and pull this off though, because that's gonna vibrate and drive everybody nuts, that hose clamp. All right, here we go. System A. Those two I don't even think are actually used because it says ice machine, and they have remote ice machine condensers now, not in this rack. System D. Gotta do this carefully, you don't want to overload anything, so. System B. And this one's our breaker right here. All right. We are running. All right, I'm gonna put some, please don't tell me there's a problem with it. I'm gonna put some gauges on it. It's gonna be under a load too. So I'm gonna slap some gauges on it and we'll check it out. I also gotta screw in all these panels too. All right, it is running its little hardaway and the sight glass is just about to clear. It's like bubble every once in a while. You can see it's just barely got some bubbles in it. But I'll give it a few more minutes. I bet you anything it'll clear. We're looking good here. This unit does not have a head pressure control valve. Someone has bypassed it, don't know why. So we don't need to worry about the flooded charge. So I'm just gonna watch it for a little bit. I'm just kind of putting stuff away, putting my tools away. I got a giant mess over here, just cleaning up my tools and everything. So yeah, we'll jump down in the box here in a few minutes, and then I'll definitely be bringing up to them about that other condenser fan motor fuse. All right, check it out. So this back bearing is bad. Notice when I spin it, it just drags. And then if I go to the front, I spin it and it flows. It moves a lot better than this one that just stops. So that was the sound that I was hearing. But you can clearly see that this thing had a bunch of water in it too. You can see rust right here. And then look at the bottom right here. So yeah, that's what happens when the motor plugs are in wrong. But the bearing, I mean, I guess that could have been it too, because it could have, no, I don't think the bearing would have gotten wet, because I don't see anything in here. This looks fine. But, all right, again, always trust your gut. If you feel like something's possibly gonna be a problem, just change it. So, and just, you know, trust yourself, especially if you're experienced. Connections right here don't look the greatest either. Yeah, this guy had a lot of water in it at one point. I'm surprised it actually dried out and restarted. It's pretty crazy. All right, well, just cleanup mode. So you never want to jump the gun. Give it time for the sight glass to clear. That one's good. All right, I'm not seeing anything too crazy. We're about, what, 20 and some change for saturation, condensing temp over ambient, 70 degrees, 75 degrees, somewhere in there. Yeah, so we're good. I'm not seeing any problems. Everything. All right, and we are down to temperature. Everything's running. We're gonna be back. We're gonna fix that other vibrating motor. All right, we are back today. What I ended up doing is I ended up coming back, pulling this motor, changing the motor and the blade because it was vibrating pretty bad, okay? Don't want to trust it. Bearings were probably damaged inside there. Relocated the capacitor, ran new wire to the motor, all the way back here, did a home run just like before, fixed up the wiring actually, zip tied it all back together as best as possible, right? I mean, it's polishing a turd over here. But went ahead and put all new fuses. Now, I think I realized, I'm wondering if something happened with that screw, because when I went to go with the wires, I did everything and then I realized there's not a screw, but luckily there's a little flag connector there that you can put a slip-on guy. Not the greatest, but you know, it is what it is. Put all new fuses, left some spare fuses, and now we're gonna turn this guy on and hope that it doesn't blow up. Okay, so here's the deal. I wired in the fan cycle switches. So condenser fan motors now should not run until compressors turn on and, you know, pressure gets high enough, then it should close the fan cycle switches. So all I should have to do here is turn on some compressors and the fan should turn on here. Just a minute, they just turned on. Vibration has calmed down. Now, this one has a different rotation on the blade, so I need to make sure it's going in the right direction. We're gonna give it a second to shut off. Just watching it, and yeah, it's going in the right direction. I just want to see it slow down a little bit more. The other one's going in the right direction. For some reason it's tripping me out, but it's correct. So we're good to go on that. One last time, and it's correct. Okay, so condenser fan motors are good, running like they should be. They're fan cycling now. Compressors are good. We had to run water on it while I was doing this. We're gonna get the lid put on and we're gonna check current on that motor. We are allowed to run 3.2 amps. We're at 2.6 on one motor, and these are both brand new motors, and the other one was amping correct the other day, but I can't get on it right now. But we're good. So that is it. This is back in operation. It's wired back in with the fan cycling like it should be. There was some extra breakers that weren't being used. I took those out and eliminated them to clean up the panel. That's pretty much it. This rack is back together. The vibration has calmed down significantly. The rack's not shaking anymore. Motors are spinning, doing what they're supposed to be doing, so we're good to go. It's really important that you trust your gut when you are going through these repairs. Now, of course, another thing that I want to explain, right? These videos do not show everything. They do not show the entire process. They do not show procedures from A to B. I show highlights, okay? Another thing that these videos do not show is my conversations with the customer. This particular customer is very, very good with listening and approving what I suggest. Now, you may think that I didn't need to pull the wire out of the second motor, but it's a really easy task when you have everything out, and it's easier to just get it done. These particular refrigeration racks, I have like 8 of these exact racks. And after so much time with the vibration from the condenser fan motors, the wires rub out inside the conduits. And it's very, very common that we have to pull new wire. Instead of chasing a ghost, changing fuses, I don't know. Is it the motor? I don't know. My customer is good with me nipping the problem in the butt, okay? So in this situation, I had a feeling that we were going to have some damage in the motor because of the plug orientation, the little weep hole plug, right? And then on top of that, the second motor was vibrating because of a bent blade. But when they vibrate, they can cause internal damage on the bearings. Both the motors were about the same age. They were like, if I had to guess, 3 or 4 years old. It was just time. So with the customer's approval, I went ahead and pulled new wire, redid everything. New motors, new blade on the left one. Did not put a new blade on the right one. Probably should have done that in hindsight, but it's fine. It'll be fine. Everything's good. The hubs are on the correct side, right? The person before put the hubs on the wrong side, defeating the purpose of the hubs. I don't understand that one, but went ahead and took care of that. Compressor was able to reset, and everything seemed to be working fine with that. But keep in mind, every time a compressor goes off on thermal, it tends to cause pitting inside the overload because the overload's opening and closing, and when that happens, it can lead to pitting inside of there, which eventually can lead to nuisance thermal overload trips or high resistance in the thermal overload that can cause overheat situations at the same time too, okay? Low voltage, different things like that. So it's not a good idea for a compressor to be going on and off on thermal overload. It's really not a good idea. And I've got lots of videos cutting them open showing the thermal overloads. So best advice I can give to everybody out there is trust your gut. You have the skills and the knowledge to repair this equipment, right? I'm sure you guys that are watching this probably have some different ways of doing what I did, and that's okay. It's okay for us to have different viewpoints, and it's okay for us to have different ways that we approach problems. This is just how my brain works and how I approach these problems, okay? I really appreciate you guys making it to the end of this video. Thank you so very much. Remember, if you haven't already, check out my website, hvacrvideos.com. We have merchandise available on there, lots of different hats. Also, if you're interested in purchasing any tools, go check out truetech.tools.com. I have an affiliate link offer code Big Picture, right? If you use my offer code Big Picture, one word, on checkout on most of the items on their website, you'll get an 8% discount. I get a small commission from that when you do that. It helps to support the channel. There's a couple other ways to support the channel. The easiest way to support all this content is literally just watch the videos from beginning to end. That's the easiest way, okay? PayPal, Patreon, YouTube channel memberships, those are all different methods. There's links in the show notes of the video for that. Again, I really, really appreciate you guys. Remember to be kind to one another, and we will catch you on the next one, okay?